Welcome to today's presentation on internal combustion engine. At its core, an internal combustion engine, or ICAA, uses fuel and oxygen to generate power through a process known as combustion. This occurs inside a special chamber called a combustion chamber, where the mixture of air and fuel is ignited. As it burns, this ignition produces high pressure and temperature gases that push against moving parts like pistons or turbine blades. This force allows these components to move over a distance, ultimately creating the power needed to run machinery and vehicles. Note: I've kept my summary concise, focusing on the key concept of an internal combustion engine and how it generates power through combustion. Internal combustion engines are classified into two main categories. Firstly, we have intermittent combustion engines, which include piston and Wankel rotary engines that burn fuel at intervals to generate power. Secondly, we have continuous combustion engines, such as gas turbines and jet engines, where fuel is continuously burned to produce energy. These different types of engines offer varying levels of efficiency, performance, and application in various industries. Internal combustion engines generate power through the combustion of fuel, producing high temperature and high pressure gases that apply direct force to components like pistons or turbine blades, moving them over a distance. This fundamental principle is illustrated in more detail by a diagram showing the various parts and mechanisms at play within the engine itself. A piston is essentially a moving part that slides up and down inside the cylinder, driven by the explosive force of combustion. It connects to a crankshaft, which converts this linear motion into rotational energy that ultimately powers the vehicle. The cylinder itself houses the piston, providing it with the air-fuel mixture necessary for combustion. The combustion chamber is a crucial part of an internal combustion engine, where fuel and air are ignited to produce power. It's located between the cylinder head and piston ring, playing a key role in the entire combustion process. The design of this chamber has a significant impact on the efficiency and performance of the engine. Spark plugs come in different types, and materials can affect their performance. Two common types are copper and platinum spark plugs. Copper spark plugs are suitable for most conditions, but they may not be the best choice for very cold temperatures, while platinum spark plugs have better heat dissipation and endurance, making them a good option for high performance engines. A hydraulic cylinder is used to lift or move heavy loads. It generates the pressure needed for such tasks from an external source, allowing for efficient and controlled movements of these loads. An internal combustion engine has several key components that work together to generate power. These components include the piston, which moves up and down, transferring energy through the crankshaft, and the camshaft, which operates the valves that allow air and fuel into the cylinder and exhaust gases. The spark plug, or fuel injector, is responsible for igniting the air-fuel mixture, and the air filter helps to clean the air entering the engine by removing dust and other contaminants. The cross-section of one cylinder in an internal combustion engine shows us that the cylinder is essentially a chamber where the piston resides and receives air-fuel mixture. This is crucial for the combustion process to take place, allowing the engine to generate power. The cylinder head contains vital components, such as the spark plug or fuel injector and valves, which play key roles in regulating airflow and injecting fuel into the chamber. The internal combustion engine has undergone significant evolution since its inception. Its practical development began in the late 19th century, marking a pivotal moment in automotive history. Since then, continuous innovations have aimed to enhance efficiency and performance, shaping the engines we see today. A car engine contains several key components, including cylinders where fuel combustion occurs, pistons that move up and down to convert linear motion into rotational energy, a crankshaft that converts this motion into torque, and valves that control airflow and fuel mixture. Additionally, there's the camshaft which operates the valves, spark plug or fuel injector, providing ignition for the fuel mixture and allowing the car engine to start and run. For those interested in learning more about internal combustion engines, I've referenced several sources throughout this presentation, including Wikipedia's entry on the topic. Thank you for watching.